probably the first two of these that from the homework, and that should help you. So 103, 104, 105, right? So I'm going to be looking off of 103 if that's okay. And let's see. Cool. All right. So so this is off of page 103. So problem number one, they give us this vertex of this parabola. Looks like it's all pattern graphed nicely. This is our parent function, agreed? Okay. So problem number one, they want us to describe what this is going to do. Shift right 3. That's it. Number two, f at x minus 3 down 3. Yeah.
Why is the first one shift right and not left?
It's always opposite when grouped.
Okay.
Always opposite. In LMAT, take your butt up, please. Number 3. Joe.
Yeah.
Shifts left 2.
Okay.
See how it's grouped? And up 3. Okay? And then number 4. Squeeze that there. 4, we have this. All I want you to really say on this one right now, if it doesn't ask you to graph it, it's not graphing at 1, 3, 5. It's graphing at 2, 6, 10. Does that make sense? Page down number 5. F at negative x. What that basically means is all of your x values are going to change. So if your vertex of your parabola is x comma y, that means this is going to yield, so this results in a vertex of being negative x comma y. Now, there's a reason why I didn't refer to our own vertex on this one. What is my vertex on this one? 0, 0. 0, 0. You change the sign on 0, it's still 0, right? So it doesn't appear that it changes. So this doesn't actually manipulate it. You just need to make note that the x value changes its value, okay? And then problem number 6, if I had this, so if I plug a negative x in, it changes the x value. If I have a negative outside of my vertex, it changes my vertex to this. Okay?
How do you know if it's a negative like 1 through 5?
So that's going to tell you.
Okay.
So this is going to tell you it's going to open opposite of what it was originally. So if it's opening up and opens down. If it's already opening down, this means it's going to open up. So that means it's going opposite, and your y value is changing. So kind of like flips over the x-axis is what happens. Okay? So some of these later problems are going to start making more sense. All right, can I move on?
Yes.
Thank you. Paste. Yes.
Are we also going to go over 105?
I'm going to go over 103, and I'm going to go over like up to number 9, and then we'll cover the rest of it later. Okay. Jeremy, let me know when you're done with that quiz. You're done? Bring it up here, please. Thank you very much.
This is for 7?
Yeah, this is number 7. Thank you. So this is our parent function that we're going to build everything else off of right now. So I'm going to do this all in different colors so you can kind of see the shifts. Okay. This goes up 2. Does that make sense? So the whole graph looks the exact same. It just happens to be starting at here. Still pattern graphs as the 1, 3, 5. But that's what this graph is doing. So that's all that took place there. Letter B, doing blue, f at negative x. What did I just say this did to our graph?
Make the x negative.
Changes the x value. So my original vertex right here is 2, my original vertex here is 1, negative 2. Okay, so that's the vertex of the original. So what is the vertex of this one going to be?
1, negative.
Did we change the x or did we change the y?
Negative 1,
Okay, so we changed the x. Okay, so I get negative 1, negative 2. So it does this over here, down here. There's no other shifting that takes place, does there? No. So it's still going to pattern graph. Oops, it's here, here. It looks like this. Okay? So remember, the black one is the one that is our original function. But that's what's taking place. So doesn't the black to the blue actually look like we just did f at x plus 2? So if it is ever on a test or quiz, you could probably give me either answer, and it's 100% acceptable, okay? And then there's one more, letter C, right? Letter C we'll do in red. So we have f at x plus 3 plus 4. So this goes left 3, up 4, right? So from my black one, I'm going to go left 3, 1, 2, 3, up 4, 1, 2, 3, 4. It still opens up with the same pattern graph. So there it is. A-okay? Cool. May I change the page? All right, I'm actually going to skip to number 9. Number 8 is going to be done very similar. If you need to see it, we could go over it next time, okay? So I'm skipping to number 9. Is that all right?
Yes.
Because this is what I want to do today. I will be handing back your quizzes. I will be going over your quizzes, okay? I'm going to go over the quiz fast. So if I don't have enough time to explain to you, why your name is incorrect at the top of the page, meaning, I try and get it done as best we can, but sometimes. All right, so 2 things I want to recognize here. We have an asymptote here, and here's my original graph. Is that okay? So if this graph shifts up or down, that asymptote moves. Make sense? If it shifts left or right only, then the asymptote stays the same. All right, so blue one will do letter A. We have f at x plus 2. This moves up 2. What moves? 2 things.
Asymptote.
The asymptote moves. So let's make this our new asymptote. Our asymptote now moves here. Is that okay? What else moves? The whole graph. Is there a point that I have identified on the original one that we can show the movement? Yeah, it's not really a vertex. It just happens to be a point that's easy to identify. So this point is the point 0, 1. If it shifts up 2, what is that point going to be then? If it shifts up 2, what's that going to be?
3,
I'm moving this way. That's the y direction. Change the y value. Change the y value.
Oh, 0, 3.
0, 3. So 1, 2, 3.
That was too easy to be thinking about that.
I know.
That was.
Here's the great thing about it. That right there is the same for every mathematical function you will ever graph in your life. That's that rule right there. So getting it all in Algebra 1. Dude. Everything else is butter. Letter B. Letter B, I have function at negative x. Okay. What does that value change? Changes the x. Now this does a few things. So how can I change my x value? I flip the graph. Which way? So does it do this?
It's easy.
because I sure as heck can't do the other. I'm not going to a headstand. Okay, so this one, the hard thing is, you still have 0, 1. Well, normally this x value would have changed, so all the x values change. So our asymptote's still the same, so our asymptote's still this. Okay, but this is what our graph's going to do. So what really happens to that entire problem is if you had a list of all the points that were on the red graph, the original, like if you had, like say 10 of them listed as ordered pairs, you would change all of your x values to be opposite sign values. But I couldn't change this one because it's 0. 0 doesn't have a negative. Okay? All right, so with that known, ladies and gentlemen, tomorrow, I will pick up page 103 and 104, okay? And then I will also pick up page
105.
I'm not worried about 105, 107 and 108. Okay? So that's what tomorrow's is. So I want to, let me pause the video. I'm going to hand your quizzes back. Just keep right all over them. Those of you who just took them, I don't have them graded yet. I'll get back to you tomorrow so you can watch the video. Okay, ready?
Yes.
Set? Can I go?
Yes.
All right, and I'm going kind of quick through these. If you have an individual question, you need to really come see me rather than hold up the rest of the class. Okay, problem number 1. We have this, f of x is equal to x squared minus 2x plus 2. Okay, we want to graph this. We don't have anything available, so I need to find the axis of symmetry first. Okay, which is x equals negative b over 2a, which is negative 2 over 2 times 1. If you don't understand where I got those from, come see me. So I get 2 over 2. So my axis of symmetry is equal to 1. Okay? If you wrote just 1 and didn't put x equals 1, you missed it. Okay? My vertex, the x component of my vertex is going to be this. I'm going to plug 1 in here. So I get 1 squared minus 2 times 1 plus 2. 1 minus 2 plus 2 equals 1. So 1, 1 is my vertex. So 1, 1 is my vertex. Can I pattern graph going 1, 3, 5 on this one? I sure can. By pattern graphing, I was able to see, thank you, I'll get this back to you tomorrow. By pattern graphing, we're able to see right here where my y-intercept takes place. That is the point 0, 2. Roots. Does it cross the x-axis ever? No. These are complex. Just write complex, please. I can't remember that. Really? Okay, axis symmetry, y-intercept, complex, 1, 1. Got it all. Good. Can I move on? It's recorded if you didn't catch it, so go and watch it. Or copy my notes. Number 2. This one will open upside down, but when it's broken up into this form, what does this point to? What's in this form? What's it pointing to? The roots. So this is going to be negative 2. This will give me negative 4 when you set it equal to 0. So my root here is negative 4, 0. My root here is negative 2, 0. Okay? So what happens halfway between my roots? The vertex as well as the axis of symmetry. The axis of symmetry is x is equal to negative 3. How do I know that? It has to happen halfway between my roots. What if I don't have roots? Well, it still happens halfway between something. Okay? So now I know my x component of my vertex. I don't know the y component, so I need to go plug this in. So I plug it in, I get negative 3 plus 2 is negative 1. Negative 3 plus 4 is 1. Negative times negative is positive. 1 times 1 is 1. So I get negative 3, 1. Okay? So this is what this looks like. If you didn't pattern graph out far enough, you can't see where the y-axis is, or y-intercept's at. So the y-intercept on this one, realize this, the y-intercept's always 0, something. That 0 is an x value. Gee, we need to plug it in someplace that has x. Up here. So I get negative. 0 plus 2 is 2. 0 plus 4 is 4. Negative blah, blah, that's negative 8. There's where it crosses my y-intercept. Did I answer all the questions on that one? Roots, vertex, y-intercept, axis symmetry. Yay! Again, if I'm going too quick, watch the video or print the notes off after this class. Number 3, I have f at x. Oh, one thing I want to point out. On this front side, you might have shifted your graph the wrong direction at first. So you might have missed 1 as far as the graph. But you did your axis of symmetry and your vertex label off of that graph and your roots off of that graph and things like that. So you might see like 1 mark, but then you're going to be going through these going, oh, but I kind of missed these. Okay, so your initial problem, you made that wrong with your plotting it, but everything else was built off it correctly. So usually that had to deal with if you shifted it right or left in the incorrect direction, or if you didn't shift it up or down correctly. So don't think, oh sweet, I'm just going to go on to the test and I'm going to plot 0, 0 as my vertex for every parabola and pattern graph right 1, left 1, up 1 off of that, and I'll just list off of that every time. It's not going to work. Okay? So you shifted it wrong somehow originally, so that's where you missed your point. So if you don't like how I did that, then I'm happy to take all 6 points off the problem. Okay, rather than 1. Okay? So I just wanted to give you a heads up on that. So if you're looking at it going, wait a minute, or some of you are sitting there going, oh sweet, he's an idiot, he didn't mark this wrong. No, there's some method to my madness. Hey, this one is actually in vertex form, agreed? So my vertex is opposite, same. My axis of symmetry is x is equal to 5. Again, I want x equals. If you didn't, I got to take a point off. So I got 5, 2. 1, 2, 3, 4, 5. 1, 2. Right there. Does this one open up or down? Down. The pattern graphs with 2. So I go right 1, down 2. Sweet, there's a point. So that's 6. Left 1, down 2. Sweet, there's a point. That's 4. So I have a root here at 4, 0. I have a root here at 6, 0. Axis of symmetry I got labeled. Vertex I have labeled. I just need now where it crosses the y-axis, the y-intercept. Okay? So y-intercept's always 0, something. That 0 is an x value. So that means you find the letter j and you plug that in, right? No, you find the letter x and plug it in. So plug it in up here. So I get negative 2. 0 minus 5 is negative 5 squared plus 2. Order of operations, exponent first. Negative 5 squared, 25. That's negative 50 plus 2. So I get negative 48. That's my y-intercept. That's not going to happen on the graph. Yeah.
Why in parentheses is there no x? When you're solving, like for the first one, -2.
Oh, because I talked it through. I said 0 minus 5 is negative 5. Or on this one, if I plugged, what did I plug in? That was the only place I plugged in, right? I was talking through it. So 0 minus 5, negative 5. Okay. If it was 3, I'd go 3 minus 5, negative 2 is there. Yeah.
To find your y-axis, you always plug 0 with the x.
To find the y-intercept, you plug 0 in for the x. If you want to find the or the x-intercepts, you plug 0 in for y and solve it, but we're not really there yet. Okay? Number 4. Number 4 looks like this. I have y is equal to x squared minus 4x plus 3. Okay, this one's not really set up to be nice yet. So I'm going to find the axis of symmetry by going x equals negative b over 2a, where my b value is negative 4, my a value is 1, negative is positive, so I get 4 over 2, which is equal to 2. So my axis of symmetry is 2. It's also the x component of my vertex. What am I going to do with that? Plug it in. 2 squared, 4. Negative 4 times 2, 8 plus 3. 4 added to 3 is 7. Negative 8 plus 7 is negative 1. Woo! Okay, 2, negative 1. 1, 2, 1. Opening up, yes? Pattern graph 135. Yep. Right one, up one. So that's 3 comma 0. That's a root. Left one, up one. Oh, there's another root. 1 comma 0. I guess you could continue pattern graphing if you wanted to find the y-intercept. So that would be left one, up 3. Oh, okay. Y-intercept 0, 3. Then you'd have this value as well as another point. Answer everything? I think so. Can I move on? I'm at 42. What did I do? Okay, again, these are all worth 6 points, so if you have any trouble figuring out how I graded something, ask me at a different time. Okay, is this one already in vertex form? And if so, what am I missing?
You're missing the plus 0.
Yeah, there's a k value out there. So my vertex to this problem is -6 comma 0. My axis of symmetry is always the x value of the vertex. Okay, I have enough information now. Plot this. Oh, sweet, -6, 0. That's also a root. Agree? Can I pattern graph 135? Yep. I'm going to go right one, up one, left one, up one, and go from there. Okay? Now, if I wanted to find the y-intercept, pattern graphing is going to be tough. I'm going to be way off my graph. So what value am I plugging in for x to find the y-intercept? 0. Okay? So, Joe, not here. 0 plus 6 is? 6 squared. That's 36 plus 0. So 0 comma 36 is my y-intercept. Yeah.
So the vertex would also be a root?
In this case, yes. Okay. Number 6. Number 6. Y equals 2, x minus 2, x plus 2. What is this one already pointing to? What is this already pointing to?
Root.
The roots. This would give me 2. This would give me -2. Because you'd set each of those equal to 0. Okay? So 2 comma 0 is a root. -2 comma 0 is the other root in this case. What will definitely happen halfway in between these 2 points? The vertex.
Also y-intercept.
Also y-intercept. Also axis of symmetry. So axis of symmetry is at x equals 0. My vertex is at 0 comma something. Okay? This is halfway between -2 and +2, right? So if I take this 0 and plug it in, I get 0 minus 2. So I have this 2. 0 minus 2 is -2. 0 plus 2 is +2. 2 times -2, -4. -4 times 2 is -8. This also is the y-intercept. Done. That's it. How are we feeling so far? On the backside. Still got time. What time we out of here? 11? Is that good? Right? Good. All right, sweet. Number 7. I get y equals -x squared plus 9. I don't have a b value, so if I don't have a b value, my axis of symmetry has to be 0. That means the x component of my vertex has to be 0. Good? How do you think I should figure out the rest? Yeah, plug it in. So -0 squared is 0 plus 9. 9. Done. Okay, yay. Axis of symmetry, we got that as well. That's already right there. XY axis. Okay. So if I pattern graph far enough, I'm going to start seeing where this crosses. My pattern graph is going to be -1, -3, -9. Okay, so down 1, Left one, down one. You okay so far? If I keep going, I'll go right one, down one, two, three. Left one, down one, two, three. Cool. If I go one more, right one, down five. I get right there. Left one, down five, right there. So the pattern graphing on this one helps you find a root at negative 3, 0 and 3, 0. Did I answer everything? Oh, y-intercept. Y-intercept happens to be the vertex, yes?
2,9.
There you go, good. We still okay? Number 8. Number 8. This one's actually set up for roots. That gives me 0, that gives me negative 4. Is that okay? What happens halfway in between the two? Vertex and the axis of symmetry. So the axis of symmetry as well as the vertex. So it looks like negative 2. So I got negative 2 comma something. Where do I figure out the y component? Plug it in. So negative 2 comes here. Negative 2 plus 4 is 2. That's going to be negative 4. Negative 2, negative 4. It's right there. This right here is a root at 0, 0. This right here is a root at 1, 2, 3, negative 4, 0. What is this also?
Root.
What also is it? It's a root and what else? Origin. What else? Think. Maybe turn around, pay attention. It's y-intercept. Thank you.
And a root.
And a root. So the y-intercept happens at 0, 0. All right, number 9, we're going to skip. Let me go to 10. Number 10. I'm just going to list your vertex real quick. We're going to build off of that. So I get negative 1, 3. If you look at it, it appears that pattern graphs starting with 2. Okay, so it's going to be 2, 6, 10. So that means my y component is y equals 2. It's going to be opposite that value, so plus 1. Same as that value, plus 3. That's my equation. Good? I'm not quite sure what's going on back here, but there's an awful lot of non-paying attention. It's pretty frustrating. Stops now, or you sit in the hall and you get to call mommy. Got it? I've seen a lot of screwing around over here. Cool it. I'm up here doing something. Okay? You don't like it, find your counselor and switch. I can refer 3 other math teachers that teach this class. Happy to have you leave. All right. Oh, we don't have to graph it because we already have a graph there. All right. 10. Domain. The domain of every parabola we deal with is this. Is that all right? The range. It's an elevator ride coming up. It's an elevator ride coming up. So we look at the y component of my vertex. Why is that? Because as I start getting up, as I get to 3 in the y direction, I can start seeing my graph. I go forever to infinity. Okay? Vertex we have listed. Axis of symmetry is that. Where is this graph increasing? Okay, increasing means this. That part of the graph. So what's the x component of my vertex? Negative 1. It's increasing all the way to infinity. Where is this graph positive? Positive, if I could write P. Where's the positive? The whole thing's above the x-axis, so where's the positive? The entire thing.
What does it mean from max to min?
Oh, I forgot that was on here, isn't it? Oh, okay, so our parabola is like this, okay, where that's our vertex at negative 1, 3. So because your parabola opens up, it's a minimum value at 3. Meaning that's the smallest y value you would ever get in this problem, no matter what number you plug in. 11. 11. It looks like we have a vertex here. It pattern graphs 1, 3, 5, but it opens down, so I have to have a negative a value. Okay, so I'm going to get x opposite of that. There's my equation. Okay, so my domain will be negative to positive infinity. My range, it's opening down, so it's coming from negative infinity. How high up the elevator will I ride this adventure?
Infinity.
That's supposed to be plus 9. No,
Plus 9.
plus 9.
Negative 1. Sorry.
Positive 9. Okay, because it opens down. So is that vertex a maximum or a minimum value? It's a max. Okay, it's the highest point of the parabola. What's the highest point of the parabola in the y direction? What's the biggest y value and get out? 9. Axis of symmetry, I haven't put yet. So axis of symmetry is x equals negative 1. Interval where it's increasing. That's where the graph is doing this. Tell me where it's increasing then. Negative infinity to negative 1. Excellent. Okay? Where is the graph positive? So let me just kind of do a rough sketch. So we know the roots. We have a root here and a root here. This whole region is where it's positive. So what's the x component of those roots? Negative 4 to what? To 2. Is this a point? No, it's the interval in which our graph happens to exist above the x-axis. Ladies and gentlemen, that is this quiz. It's recorded for you. So I would say, things that you know, let's go back here a few boards. I don't know, where here? No, here. So this is what our homework is. Make sure both of these pages are complete. Yes, I understand there's a third page to each of those. Don't stress those. Just get the 103, 104, 107, 108. Done. Okay? So this week, it's Wednesday already, right? So this is Wednesday stuff. Thursday, we'll have some more stuff we'll deal with. Friday, some more stuff. So that takes care of this week. Okay, we're pretty much finished with the chapter. Then come next week, Monday. Monday, we have a little bit of review. Tuesday, take home test. Got it? Wednesday is a goofy day. We only have periods 1 through 4 that day. So you guys get a bonus day. You get that bonus day to work on the take-home test. Okay? Thursday, next week, is test part 1. Friday is test part 2. Okay? Bless you. Now, guys and girls, a lot of stuff that's on that quiz that's sitting there with you right now. There's only actually one new concept that we learned. And that's the shift right, left, up, down. Okay? So if you were to study that, go over the video, look at that, nav it down. Don't do it the morning of Thursday thinking, oh yeah, this is all going to come back to me. Man, I got a 2 out of 75 on the quiz. It'll all come back to me. I just watch the video while I'm eating my Cheerios. Hate to tell you something, but you ain't playing school the right way. Oh, but I'm busy. I know. Your full-time job is being a student. Is if you're sitting there playing video games all day long, nonstop, I'll tell you what, I have no problem seeing you next year in the same class. No problem. It's pretty unfortunate that you guys are part of a generation of video games that take nonstop to play. It's really unfortunate. It's doing a very big disservice to your future, I will tell you that. Well, I'm going to be a video game programmer. No, you're not. How do you know? You haven't even taken a computer course yet. Yeah, but I'm good on my phone. Yes.
One of these boards has no options.
Nope. Yes. Always. All right, that's all I got. I'm saving this.